press the bell icon on the YouTube app and never miss another update.
Next question. If the function f defined as f of x equal to so and so when x not equal to 0, it is continuous at x equal to 0, then find k and f of 0. F of 0 means functional value of f of x at x equal to 0. Okay, already it is given as f is continuous at x equal to 0. So therefore f of 0 is equal to limit x tends to 0 f of x. X tends to 0 means x not equal to 0. So where is x not equal to 0 case? Here is. So therefore that is equal to limit x tends to 0, x tends to 0, f of x. First simplify, first stage, simplification. E power 2x minus 1 minus k minus 1 into x whole divided by x into e power 2x minus 1. Now put x equal to 0 directly. Then e power 0, 1, 1 minus 1, 0, 0, 0. It is 0 by 0, which gives 0 by 0. That's why we are applying L'Hospital rule. So that is equal to limit x tends to 0, e power to x differentiation e power to x into 2 later minus 0 minus k minus 1 whole divided by u into v x into differentiation 2 e power to x, right, plus e power to x minus 1 into x differentiation 1. So just simplification, limit x tends to 0 to e power to x minus of k minus 1 whole divided by x into 2 e power means what? 2x means 2x e power 2x plus 1 into means same e power 2x minus 1 minus 1. Okay, now here we see that as here as x tends to 0, already I said the logic, x tends to 0, denominator is equal to 0. So therefore numerator also equal to 0 as x tends to 0. Already I said this is shortcut. So therefore here as x tends to 0, put x equal to 0, denominator 0. So therefore 2 into e power 0 minus of k minus 1 is also equal to 0. So 2 minus k plus 1 equal to 0, then k equal to 3. So we got one value, k value 3. Where is that? Here is k equal to 3. So therefore definitely third and fourth options are wrong. Our correct answer will be in either first option or second option. Okay, k is equal to 3. Next, let us substitute, that is back substitution method. Put k equal to 3 in this limit value. Okay, so therefore that is equal to limit x tends to 0 to e power to x, k value 3 minus 2 minus 2 whole divided by 2 x e power to x plus e power to x minus 1. Okay, next time put x equal to 0 here. So it is 0 by 0. Again we are applying L'Hospital rule. So on putting x equal to 0 directly, it is again taking the indeterminate form 0 by 0. That's why we are applying L'Hospital rule. So that is equal to limit x tends to 0, you come here 2 2 into e power 2x differentiation, e power 2x into 2 whole divided by 2 into UV method, x into e power 2x into 2, okay, u b dash plus v u dash, okay, next plus e power 2x differentiation 2 e power 2x, okay, next here 2 common cancel, so that is equal to, put x equal to 0, so 2 into 1 divided by putting x equal to 0, it is equal to 0, 0 plus 1 that is equal to 2 divided by 1 plus 1, 2, that is equal to 1. So therefore, what is that? It is f of 0. So therefore, f of 0 that is equal to 1. Answer 3 comma 1. F of 0 1. So second option is right. Hence the point. Let f from capital R to capital R, real number set, domain, codomain, capital R, real number set, be a function defined as so and so. Then f is what? He said like that. Okay. First, this is the real line. So numbers 1, 3, 5. This is 1. This point is 1, 3. Next 5. Okay. It is defined as x less than or equal to 1. X less than or equal to 1 means in this area, this is x less than or equal to 1. It is defined as constant function 5. Next 1 to 3. 1 to 3 means just some gap, means greater than 1. Next less than 3. Less than 3. Here it is defined as a plus b x. Next 3 to 5. 3 open interval of 3 means is equal to, here is equal is there, therefore we are considering 3 also, because it is given is equal to relation, then it is b plus 5x, b plus 5x, 5x less than 5, like that. Next greater than or equal to 5. In this area it is defined as 30, constant function. Okay. So therefore breaking points, this is the breaking point, this is the breaking point, this is the breaking points. So therefore breaking points x is equal to 1 comma 3 comma 5. Understand? So first heading at x equal to 1, at x equal to 1, at x equal to 1, left hand limit that is equal to left hand limit means what? It is x is less than 1. Where is x less than 1 area? Here is. It is directly defined as 5. Okay. Next RHS, RHL that is equal to. It is what? Greater than 1. Greater than 1. Greater than 1 means this is x greater than 1 area. It is what? X is greater than 3 area. Understand? Okay. This is what? It is x is greater than 5 area. Of course, closed interval is there. Therefore, we can use is equal to also. Understand? Right? Greater than 1 area. A plus B x means x equal to 1. Put like that. So that is equal to a plus b. And what about f of 1 value? F of 1 is equal to f of 1. F of 1 means x equal to 1 case is here 5. That is equal to 5. So therefore LHL is equal to RHL a plus b. That is equal to 5 if it is continuous. Understand? We are assuming continuous. Assume that f is continuous. Okay. First we take some assumption. So that implies a plus b, that is equal to 5. This is, let it be equation number 1. Later, assume that f is a continuous at x equal to next to point 3. This is also assumption. Assume. Okay. Next, left hand limit is equal to means what? It is x less than 3 area. Where is x less than 3 area? X less than 3 area. This is x less than 3 area. X less than 3 area means this one. So this one. So a plus b into x3. So next, and what about right hand limit? That is equal to, it is what? X is greater than 3. X is greater than 3. This is x greater than 3 area. So b plus 5 into x3. So that is equal to b plus 15. And what about f of 3? F of 3 means x equal to is here. So x equal to 3 means this one, or this one. So again b plus 5 into 3, that is equal to b plus 15. So therefore, if it is continuous at x equal to 3, then left hand limit means a plus 3b, that is equal to b plus 15. So that implies a plus 2b, on simplification it is 15. Okay, let it be second equation. Next, third one. Assume that f is continuous at x equal to 5. So therefore, left hand limit means what? X is less than 5. So that is equal to, where is x less than 5 area? Here is x less than 5 means this one. So b plus 5 into x5. Of course, that is equal to 25 plus b, and RHL, that is equal to right hand limit. Right hand limit means it is x is greater than 5. Where is x greater than 5? Constant. That is equal to 30. And of course, f of 5 is also 30. So therefore 25 plus b, that is equal to 30. Then b equal to 5. Let it be equation number 3. Understand? So therefore, by using third equation, the second becomes second implies a plus 2b, that is equal to 15. That implies a plus b 5. 2 5 is 10. That is equal to 15. A equal to 5. But therefore, a equal to 5 and b is also 5 are not satisfied. Equation number 1. A is what? Actually, equation number 1 says as a plus b is equal to 5. A is what? 5. B is what? 5. 5 plus 5, 10. Is 10 equal to 5? No. Therefore, not satisfied by the equation number 1. If it is satisfied, then it is continuous for a equal to 5 and b equal to 5. But it is not satisfied. Therefore, not continuous for any values of a comma b. Once again, if a comma b are satisfied equation number 1, then we can write it it is continuous for a equal to 5 and b is equal to 5. Means third option will be right in such a case. But here our result is a comma b are not satisfied equation number 1. Therefore, fourth option is correct. Means what? If f is a continuous function in the given intervals, then definitely a comma b will satisfy by total 3 equations. Otherwise, it is not continuous. Hence, important question. If f of x equal to box of tan x into again box of cot x, x belongs to closed interval of pi by 12 comma pi by 2. So find the number of points of discontinuity in this interval. Understand? This is the given function. In this interval, how many number of points of discontinuity are there for f of x? Okay. Here, what tremendous formula is there? Box of cot x is equal to cot x. If cot x is an integer, box of cot x is less than cot x. If cot x is not belongs to integer. This is the most important formula, right? Okay. Here f of x equal to box of tan x into, what about box of cot x into cot x. If cot x belongs to I, understand? So that is equal to tan theta into cot theta is equal to 1. So box of 1 comma, if cot x that is belongs to integer. Next, and f of x equal to box of tan x into, it is less than means this value is something less than one value. If cot x that is not belongs to I, so any value means 0 to 1, it is 0. Okay, so therefore if cot x not belongs to I, okay, you come here. What I am telling that consider, I will give the complete explanation. Tan x into box of cot x value, this is equal to tan x into box of cot x equal to cot x if cot x is an integer. Okay, next, that is equal to tan x into this box of tan x is less than cot x, if cot x is not belongs to I, right? Actually this is tan theta into cot theta 1, so 1 if cot x that is belongs to I. Next, this is less than 1 if cot x is not an integer. So total, what is its box? 1. If this is belongs to I, what is its box? Means less than 1, 0. Its box value 0. That's what I wrote here. So therefore finally f of x is defined as 1 if cot x belongs to I, that is equal to 0 if cortex not belongs to I. Belongs to I one case, not belongs to I another case. In both cases it is different. So therefore f of x is discontinuous at cortex that is belongs to I. Right, now we have to find where cortex is an integer in this interval. So for which you come here, for which x belongs to closed interval of pi by 12 comma pi by 2 open. Understand? Therefore that is pi by 12 is less than or equal to x is less than pi by 2. Apply cut on both sides. 1 minute. You come here. For example, a less than or less than or equal to, okay, x less than b, then we can write f of a is less than f of x is less than f of b, means following the same signs. Understand? If f of x is an increasing function in open interval of a comma b. Understand? Right. Next, it implies f of a, reverse sign, opposite sign, greater than f of x is greater than f of b. Just applying f means it is less than, but it is opposite sign, less than opposite sign. If f is a decreasing function in open interval of a comma b. This is the tremendous formula in calculus or trigonometry. Right. Here what I am telling that cortex is a decreasing function in all quadrants. Before that, tan x is an increasing function in all quadrants. Remember, therefore we are using this formula. Cortex is a decreasing function, so that implies cot of pi by 12 is opposite sign, greater than or equal to cortex is greater than cot pi by 2. So cot pi by 12 is what? Cot pi by 12 means cot pi by 12, that is equal to cot 15 degrees. Cot 15 degrees means it is 2 plus root 3. Okay, so therefore it is 2 plus root 3 is greater than or equal to cot x is greater than 0. So that is imply 0 less than cot x less than or equal to 2 plus root 3. Root 3 approximation value 1.7. 1.7 plus 2, 3.7. So it is 3.732 something like that. Okay, so therefore in this interval, so this is 0, this is 1, this is 2, this is 3 and 3.7 something. Okay, open interval means this area, open interval of 0 to less than or equal to 3.7. So therefore total in this area cortex takes the the integers 1, 2, 3, 1 comma 2 comma 3, just like that. So therefore you come here, therefore f of x is discontinuous at cot x equal to 1, cot x equal to 2, cot x equal to 3. Okay, so that implies it is what x equal to cot inverse of 1. It is what x equal to cot inverse of 2. It is what x equal to cot inverse of 3. Understand? So how many values are there? 1, 2, 3 in this interval. So therefore at 3 points it is discontinuous. Hence the problem. Topic important small topic. Different kinds of discontinuity. Different kinds of discontinuity. Number 1. Isolated discontinuity. Isolated discontinuity. First definition is what? Left hand limit is equal to right hand limit or limit extends to a f of x exists. Left hand limit, right hand limit means at x equal to a. It is at x equal to a. But limit extends to a, f of x is not equal to f of a. The complete meaning is left hand limit is equal to right hand limit that is not equal to f of a. Then it is called isolated discontinuity. Example. This example is also important. F of x is equal to modulus of 2 into sinum of 2x plus 2. This is the best example. Here already I said the sinum function definition. SGN sinum of x equal to plus 1 if x is greater than 0. That is equal to minus 1 if x is less than 0. That is equal to 0 if x equal to 0. Okay. So therefore in this function f of x equal to, first we will take x greater than 0 case. So x greater than 0 means sinum of 2x is 1, means modulus of 2 into x greater than 0, 2x also greater than 0, it is also greater than 0. So into 1 plus 2. So that is equal to 1 is 2. Modulus of 2, 2. 2 plus 2, 4. So total 4. Next case. If x is less than 0. X is less than 0. So modulus of simplification part 2 into this value is minus 1 plus 2. So modulus of minus 2 plus 2. Modulus of minus 2 is 2. 2 plus 2, 4. So this is 4. Next. If x is equal to 0. X equal to 0. Then sinum x 0. Sinum of kx is 0. So 2 into 0. 0. Modulus of 0. 0. 0 plus 2. 2. So this is complete meaning of f of x. So therefore clearly left hand limit, at x equal to, so which one is the breaking point? 0. So at x equal to 0, LHL equal to 4, that is equal to RHL, but it is not equal to f of 0. So therefore f of x is isolated discontinuous function. Isolated discontinuous function. So this is the best example. Next, number 2. Okay, so this is isolated. This is the isolated. Next, number 2, missing. Number 2, missing discontinuity. Missing discontinuity. It is what? Left hand definition. Left hand limit is equal to right hand limit, or limit extends to a, f of x exists, but f of a does not exist. F of a does not exist. Understand? Next example, for left hand limit equal to right hand limit, or limit exists but f of a does not exist. Example, limit extends to 0, the function is f of x. Okay, I will write directly the function sin x divided by x. Limit extends to 0, sin x divided by x. Actually this is standard formula 1. For example, it is f of x. Let it be, this function is f of x. So therefore clearly f of 0, that is equal to sin 0 by 0. It is does not exist. Okay. So therefore the function f of x is equal to sin x divided by x is missing discontinuous function. At x equal to 0. So therefore here is an inference. Note. What is that? Either isolated discontinuity, or missing discontinuity is called removable discontinuity. You come here. This removable discontinuity is called first kind of discontinuity. So therefore, if f of x isolated discontinuity, then we can say it is removable discontinuity, or it is first kind of discontinuity. If it is missing discontinuity or discontinuous function, then it is a removable discontinuity or first kind of discontinuity. This is the most important point. So, isolated discontinuity or missing discontinuity is called removable discontinuity or first kind of discontinuity. Okay, let it be. This is Roman number 1. This is one lesson. Next, second lesson. Number 2. Roman number 2. Roman number 2. So, first one. Listen, first one. Capital A. Number 1. Jump discontinuity. Jump discontinuity, or it is called finite discontinuity. Finite discontinuity. What is the definition? Is a simple definition. Definition. Left hand limit is not equal to right hand limit. Understand? So, if left hand limit is not equal to right hand limit, then it is called jump discontinuity or finite discontinuity. Example, f of x equal to, f of x is equal to modulus of x divided by x, comma, x is not equal to 0. So, first left hand limit at x equal to 0 means x is less than 0. So therefore limit x tends to 0 minus, okay, 0 minus means x is less than 0. X is less than 0, modulus of x is minus x divided by, in the denominator x is there, on cancelling it is only minus 1. And right hand limit is equal to limit x tends to 0 plus means what? X is greater than 0. X is greater than 0. When x is greater than 0, then modulus of x is equal to plus x. So therefore plus x divided by x. So that is equal to plus 1. So therefore left hand limit is not equal to right hand limit. So therefore f of x that is equal to modulus of x divided by x, whereas x is not equal to 0, has jump discontinuity or finite discontinuity. Next number 2, capital B. So jump is over or finite is over. Next finite is over. Infinite discontinuity. Infinite discontinuity means either LHL or RHL is either minus infinity or plus infinity respectively, or limit x tends to a f of x that is equal to infinity. Infinity means either plus infinity, we can write plus infinity or minus infinity. Example. Limit x tends to 0 cos x divided by x. Actually, as x tends to 0, cos 0 1, 1 divided by 0 infinity, it is plus infinity. So therefore f of x that is equal to cos x divided by x, x has infinite discontinuity at x equal to 0. Next, number C. Third one. Oscillatory discontinuity. For example, oscillatory discontinuity means what? Limit or definition. Limit of a function oscillates between two fixed values. It is the definition. Actually, example, f of x equal to sine of 1 by x, comma, x is not equal to 0. Then what about means limit extends to 0, sine of 1 by x is what? 1 by x is what? This is our question. Okay, let us see the graph. Listen, this is x-axis, y-axis, origin. Suppose it is +1 maximum value, +1 minimum value, -1. This is +1. This is -1. Here, put x equal to 0. 1 by 0 infinity means what? As x tends to 0 plus means right hand side, it is tending to infinity, like that. So the graph will be like that. As x tends to infinity, put x equal to infinity. 1 by infinity 0, sine 0 0. So it is going on like that. As x tends to infinity, y 0 means f of x value 0, like that. It is nothing but 0 plus. It is means in this direction x tends to 0 plus. It is infinity. Understand? Right. You come here. X here left side means 1 by -0 means minus infinity. Understand? So the graph will be minus infinity, like that. Understand? Means this is 0 minus left hand side. Actually this is 0 plus. This is 0 plus. 0 plus infinity. 0 minus infinity, like that. As x tends to minus infinity, 0 means like that. So the graph will be like that. Understand? Like that. Here also. Like that. It should not be exceeded by +1 and -1. +1, -1. These are two fixed values. Understand? So it is called oscillatory discontinuity. For example, f of x equal to sine of 1 by x. Okay. over. So therefore, the inference, what is that? What is that? Important note, very, very important note. Number one, jump, isolated over. Next, jump, discontinuity, or infinite discontinuity, or oscillatory, discontinuity. These three are called, its opposite meaning. It is what? Removable. Its opposite meaning, irremovable or non-removable. So it is irremovable or non-removable discontinuity. Discontinuity. Understand? Next, or first kind of. Already first kind is over now. This is the second kind of. It is first kind of. This one is second kind of discontinuity. So here, if the given function is jump discontinuity, then it is called irremovable or non-removable discontinuous function, or simply it is second kind of discontinuity. That one is first kind of discontinuity. This one is second kind of discontinuity. First I said in Roman number 1. Understand? Second I said in Roman number 2. So if it is infinite discontinuity, if f of x has infinite discontinuity, then it is called irremovable or non-removable discontinuity, or simply it is called second kind of discontinuity. If the given function has oscillatory discontinuity, then it is called irremovable or non-removable or second kind of discontinuity. So therefore, these three are related to irremovable or second kind. Next, these two are related to removable or simply first kind of discontinuity. This lesson is very, very important. Make a note.